Welcome! Today, we're doing more than just learning geometry. We're actually going to equip you with a brand new Builder's Toolkit. Together, we're going to unlock some really key secrets about the shapes you see all around you every single day.
Okay, so let's just dive right in with a question. Imagine you grab any three sticks you can find. Could be pencils, could be branches, whatever. Can you always, and I mean always, lay them end to end and make a perfect triangle? I mean, it kind of feels like you should be able to, right?
This is what I'd call a builder's first question, because it really gets to the heart of something super important: structural stability. It seems almost too simple, but there's a hidden rule here, a fundamental law of geometry that every single builder, every architect, every engineer has to know. And the surprising answer is a hard no. You absolutely cannot build a triangle with just any three sticks you happen to pick up. So the big question is, why not? Let's dig in and add the very first and maybe the most important tool to your new geometry toolkit.
Okay, this first tool is something I like to call the triangle test. Think of it as your go-to check. It's essential for figuring out which combination of side lengths will give you a sturdy, solid shape and which ones are just going to fall flat, literally.
Now, the official name for this rule sounds a little fancy, the triangle inequality theorem. But honestly, it's beautifully simple. All you do is take the two shorter sides, add their lengths together, and that total number has to be bigger than the length of the longest side. And I mean strictly greater, not equal to, not less than.
And here's the logic behind the math, which makes perfect sense when you think about it. If those two shorter sticks, when you put them together, aren't long enough to span the distance of that longest side, well, they just can't meet up to form that third corner. They'll just collapse inward. It's just simple physics working hand in hand with geometry.
And this table just illustrates it perfectly. Let's look at the first case. You've got sticks with lengths 3, 4, and 8. So you add the two shorter ones, 3 plus 4, which gets you 7. Now, is 7 greater than the longest side, 8? Nope, not even close. So it fails the test. You can't make a triangle. But check out the second case. Sides are 5, 5, and 8. You add the two shorter ones, in this case 5 plus 5 is 10. And since 10 is greater than 8, bam, it passes the test. You've got yourself a real, stable triangle.
All right, let's move on to our next tool. We're going to see how we can build on this to solve even more complex figures. We're graduating from simple triangles to, well, shapes that look like they've been stitched together in a mad scientist's lab.
The technical term is a composite figure, but I just love calling them Frankenstein shapes. And once you start looking for them, you see them everywhere. The L-shaped room in a floor plan, a company logo, all over the place. They might look intimidating, but with this second tool, you've got two awesome power moves to solve them, no sweat.
Okay, strategy number 1 is my personal favorite, decomposition. You basically get to play surgeon. You take this weird, clunky shape and you slice it up into simple, friendly pieces you already know how to work with, like rectangles and triangles. Then you just find the area of each little piece and add them all up for the grand total. Easy. Now, strategy number 2 flips the whole script. Instead of adding things up, you subtract. You look at the shape and you imagine it as one big solid block, maybe a giant rectangle. Then you figure out the area of the piece that's missing, the hole that's been cut out. Subtract the area of that hole from the area of the big block, and whatever's left, well, that's the area of your Frankenstein shape.
All right, time for our final tool. And this one isn't really about finding the answer. It's about how you communicate your solution like a pro. Because, let's be honest, getting the right number is only half the battle. Explaining how you got it is just as crucial.
So here's the key takeaway. Showing your work isn't just some random rule from math class. When you write the equation first, you are creating a blueprint. You're laying out a clear plan that literally anyone can follow to understand your thinking and check your results. It's the language of engineering, of design, of building things that work. And just look at the difference here. On the left, you've just got the answer. The height is 5. Okay, great. But on the right, you have the full story. You start with the formula, the rule you're using. You plug in the numbers you know, and then you show the step to find the piece you're looking for. One is just a random fact. The other is a repeatable, verifiable process. It's a blueprint.
And just like that, you've done it. Seriously, in just a few minutes, you've added 3 incredibly powerful, really practical tools to your problem-solving belt. So let's do a quick recap of your new toolkit. First up, you've got the triangle test. With the triangle inequality theorem in your back pocket, you can now look at any 3 side lengths and know instantly whether they can even form a stable, functional triangle in the first place. Second, you have the shapeshifter.
Now you're armed with two totally different strategies: adding by breaking shapes apart, or subtracting by cutting out holes. You can confidently find the area of any weird Frankenstein shape that comes your way. And third, you've got the blueprint language. You now get that showing your formula and your work isn't just about getting credit. It's about communicating your logic with the same clarity and precision as an architect or an engineer. So, from now on, when you look at a building or a logo on your coffee cup or even a piece of furniture, don't just see a shape. See a puzzle that you now have the tools to solve. So, I'll leave you with this. What complex shapes are you seeing around you right now that you can finally break down and understand?